This is a quick tutorial video on how to do the gate wheel assembly problem. So if we have a look at the question in the lecture slides, first thing we need to do is we need to identify the individual components. So if we look at the top left, we've got the three views of the component. This is the main view, right hand, and the top view. It's got a groove through the middle that's 40 high, 50 wide. And in the top view we've got M10 mounting holes or threaded holes, 4 of them. They are 60 apart in the vertical direction, 100 apart in the horizontal. The block is 100 by 140 by 100 high. To the right of that we've got a bolt, M10, so it means the diameter of the bolt is 10 millimeters with a metric screw thread at the end. The thread has a length of 20 millimeters, and there's a small hole drilled through the thread. Usually if you see a thread with a hole drilled through it, you know that a castle nut and split pin will be used. To the right of that we've got the wheel. It's got a diameter of 100, inside diameter of 10, width of 39 on the outside, and then the V profile is given by these dimensions. Bottom left we've got three views of like an L-shaped component. It's 15 wide over there. The bottom is also 15 high. I get the 15 from 50 minus 35. There's a 10 millimeter hole drilled through it, 15 from the top. And it's got two holes in the horizontal part, 60 millimeters apart, and their diameter is 11. Okay, 60 apart, close to 10 diameter. We've seen this before somewhere. Okay, bottom right we've got another L-shaped component, but this one has a little slot cut into it. The slot has a width of 15, also has a diameter 10 hole in the middle, and the rest of the dimensions are the same as the other L-shaped component. Good, so now we can use these dimensions to get relationships or figure out the relationships between the various components. So we saw that the 60 and this hole 11 with this M10 do correspond. So this plate corresponds to the one side, that plate corresponds to the other side. Those are the same. So which one is on which side does really not matter at all. So the two plates can get put in place at the top there. One must notice that this grey block has a total width of 140. These L-shaped components have a width of 50 each. So that means the gap in the middle there is 140 minus 50, so that's a 40 millimeter gap in the middle. But in this component it is 50, so just note that there will be a 5 millimeter step on that side and a 5 millimeter step on that side. Next thing would be that this bolt of ours has a head size of 15. This groove in the one L-shaped component has a width of 15, diameter 10 from the M10, and this diameter of the hole, which is also 10, corresponds. So I can actually put the bolt through this hole all the way through. Now what this groove will do is it would actually act like a mechanism to stop the bolt from rotating. So putting the bolt through that hole means the wheel or whatever we put on the inside is not able to turn this bolt, which is very beneficial, because if we put a nut on the other side, it means that it can never undo the nut by itself. The wheel had a diameter of 10 on the inside, width of 39. Now you'll remember earlier when I said the width between this plate and that plate is 40, we can now see that the wheel width of 39 would fit in there, but it would have a 1 millimeter clearance. Usually we like those clearances because a small clearance means that the two plates on the side, the L plates, won't cause excessive friction on the wheel from the sides, so that the wheel can move freely. So sometimes standard components are not drawn in the question. This is because the dimensions of these standard components are pretty much standard, so there's no point in specifying the details of something which is off the shelf or standard. So these include uh, bolts and nuts and circlips and washers and all kinds of standard components. Now in this assembly, we were given that this grey block had 4 M10 holes in it, but we weren't given the M10 bolts in the question. These M10 bolts are standard components, and it was necessary for me to add them in to my drawing because they are used to keep these L-shaped components onto the top of the grey one without it falling off. Usually a hole in a thread or in a portion of a thread indicates that a castle nut and split pin will be used. Those are also standard components, also not drawn in the question. So there we have it. The castle nut was screwed on and the split pin gets pushed through the castle nut and then bent open on the other side to make sure that it won't fall out by itself. So if the split pin, the blue one, cannot fall out, it means this castle nut is not able to undo by itself. You have to first remove this blue component, pull it out, before this castle nut can rotate relative to the bolt. Okay, so now we have the external views of the assembly, and then we can add our dimensions. Remember, with assembly drawing we've got overall dimensions, functional dimensions and mounting dimensions. We don't have any specific mounting dimensions. You could have given the spacing of these bolts as a mounting dimension, but I'm not too worried about that now. Remember the 1mm gap. It is very important for you to actually draw it in place, because if you don't draw it there, then it would seem like those L brackets, this one and that one, are actually used to clamp onto the wheel, where in this case there's actually an intentional gap to make sure that the wheel is free to rotate.